You know, we always hear about AI needing tons and tons of data, right? Millions of examples. But what if that's not the whole story? What if the real magic isn't in the individual facts, but in the connections between them? Today, we're going to dive into this really cool idea, how an AI can learn about the world pretty much the same way we do, by looking at its friends.
All right, so to really get this, let's not start with code or algorithms. Let's start with a story. And for that, I want you to meet someone. This is Sam. So, it's Sam's first day at a brand new school. You know that feeling, right? He's a little lost, trying to figure everything out. He walks into this new classroom, it's buzzing with people, and he's just trying to get a read on the room, trying to see where he might belong.
Okay, so this classroom is, well, it's a little different. You've got a few students wearing these bright red badges that say, "I love math." Then there's another small group with blue badges that say, "Math is not my thing." But here's the thing, most of the students, no badge at all. And that includes our guy Sam. So we have these tiny pockets of information, but pretty much everyone else is a total question mark. Sam spots an empty seat and sits down next to a girl named Aisha. She seems pretty cool. She's working on a Sudoku puzzle and, what do you know, she's wearing one of those red I love math badges. They start talking, and just like that, a connection is formed.
So then, Aisha introduces Sam to her friend Rahul. And you guessed it, Rahul's also got a red badge. He's super into it, invites Sam to come hang out at the math club. See what's happening? That little network of friendships is starting to grow, and it's pulling Sam right along with it.
Okay, so fast forward a few days. Sam's been hanging out with Aisha and Rahul. Maybe they're doing some math quizzes, whatever. What's your gut feeling about Sam now? He's not wearing a badge. We still don't officially know. But you'd bet he's a math guy, right? Of course you would. You're making a guess, a prediction, based entirely on who his friends are.
All right, so that's a cute story about a kid fitting in. But what in the world does any of this have to do with AI? Well, as it turns out, it has everything to do with it.
Because this story about Sam, it's basically a perfect, real-life example of a super powerful AI technique called semi-supervised learning. Just think about it for a second. In that classroom, we had a tiny amount of information we were sure about, the kids with the badges. But then we had this huge amount of unlabeled data, all the other students that we knew nothing about.
Let's actually break this down. Let's map it out. Every student in that room, that's a data point. In the AI world, we'd call that a node. The friendships they form, those are the connections, or edges that link them together. And those red and blue badges, that's our labeled data, the little bits of ground truth we have. And Sam, well, he's the big one. He's the unlabeled data point that the AI is trying to solve for.
The whole thing, the entire idea, hinges on one simple but really powerful assumption. Things that are connected are probably similar. Birds of a feather flock together, right? In AI, there's a fancy term for this, the manifold assumption. But honestly, it's just common sense. You figured Sam liked math because his friends did. The AI does the exact same thing. It lets that information, that badge color, just flow through the network of friendships.
Okay, but how does the AI actually do this? Like, what are the steps? It's not just some kind of magic. It's actually a pretty straightforward process. I like to think of it as a simple three-step recipe. Step 1, you build the graph. You connect all the dots, literally. Every student in the classroom gets linked up based on their friendships. Step 2, you assign the initial labels. You put those red and blue badges on the few students you already know about. And then, step 3, this is the fun part, you let an algorithm spread the influence. It lets that badge color just flow out to all its neighbors and then their neighbors until everyone in the network has a pretty good guess for a label. And you know what's really cool about this? We can actually watch it happen. This isn't some black box where you put data in and an answer pops out. We can literally see the process unfold, step by step, as the AI thinks. All right, let's look at a super simple example. We've got 6 data points here, A through F. Now, we only know 2 things for sure. Point A is labeled C0, let's call that our red badge. And way over on the other side, point F is labeled C1. That's our blue badge. Everything else in between, B, C, D, and E, total unknowns. And this table just lays it all out perfectly. Look at the start, iteration 0. We only know A and F for sure. But then, after just one step, iteration 1, look what happens. The influence starts to spread. B and C, they're next to A, so they start leaning red. E is next to F, so it starts leaning blue. And then there's poor D, kind of stuck in the middle, getting pulled in both directions. But as the algorithm keeps running, the stronger, closer connections win out.
The whole thing stabilizes, and even D, our ambiguous point, gets confidently pulled over to the red team. Just like that, the labels have propagated across the whole network.
So, look, this is way more than just a cool thought experiment. The really crucial thing to get is that this exact technique is out there in the real world, right now, solving some seriously massive problems. I mean, just think about it for a sec. A social network trying to guess your interests. It looks at your friends. An e-commerce site recommending a product. It looks at what people like you bought. Scientists trying to categorize a new research paper. They look at the other papers it cites. Basically, anytime you have a mountain of data, but labeling it all by hand would take forever or cost a fortune, this approach is an absolute game changer.
All right, so if you're going to remember just a few things from this, what should they be? First, you don't always need a bazillion perfectly labeled examples to build a really smart AI. Second, the structure of your data, the relationships, the connections, that can be just as valuable as the data itself, maybe even more so. And that leads to the third point. This whole method makes powerful AI way more accessible, especially when getting those labels is super expensive or just plain hard.
And that kind of leaves us with one last big idea to think about. You know, in this world of big data, we're always so focused on collecting more and more individual data points. But what if we're missing the forest for the trees? What if the most important information, the really deep insights, aren't in the data points at all, but in the connections between them?